Okay, hi everyone, it's Samantha. I'm one of the Chem001C SIs for Dr. Jang. If you have any questions about this video, please feel free to comment down below, email me, or attend any of my office hours. The hours are Monday 10 through 11, Thursday 11 to 12. And with that, let's get started. So today we're going to be going over parts of Chapter 17 that have been covered in lecture. And more specifically, I'll be going through Week 8, Worksheet 2. So with that, let's get started. So week 8, Worksheet 2 covers mainly electrodes. So I'm going to actually erase this so that we have space. But the first question asks us to put this equation or this reaction into cell notation. Now, how do we do that, right? If we know that we have this, essentially this reaction, well, what does cell notation ask us to do? Cell notation wants to know what's behaving as a cathode and an anode, right? But what is a cathode and an anode? Well, cathodes and anodes are both electrodes, right? It's just a matter of what is doing what. An anode is the electrode where something is oxidized, and the cathode is where something is reduced. And if you remember from last quarter, you gain an electron to be reduced, and you lose an electron to be oxidized, right? And then when we put in cell notation, it has to be cathode, double line to separate the two, or I apologize, not cathode. Anode, double line, cathode. Right? Now, from this, can we identify what is behaving as our cathode and what is behaving as our anode? Well, how do we even do that, right? How do we separate what's being reduced or what's being oxidized? Well, we look at the half reactions. And if we look at the half reactions, I'm going to put them up here. We have Pb goes to Pb2 plus, and Cu2 plus goes to Cu. Well, if we look at that here, we know that it can't just stay the way it is because the charges have to be balanced. We know that this starts off with a charge of 0, but this has a charge of 2 plus. That's not balanced, so we balance this out with 2 electrons. And then we balance this out with 2 electrons. And if that's the case, we know that this loses electrons, but this gains electrons, right? So if this is gaining, we know that our Cu is our cathode and our Pb is our anode. Now, to put that in cell notation, we then go essentially in the order of our reaction. It goes Pb, line, Pb2 plus, double line to separate our anode and our cathode, and then again in the line of the reaction, Cu2 plus, line, Cu. And remember, this is aqueous. It goes solid, aqueous, aqueous, solid, because we need to have the correct states associated with our molecule in reaction. Now, that's just question 1, right? Moving on to question 2, we have to look at it on the opposite side, wherein what if they give it to us in just cell notation? And question 2 essentially asks us the question this way. If you're given Al, S, Al3 plus, Fe, 2 plus, Fe, right? What if it were given to you this way? How would you write the balanced chemical reaction for that cell notation? Well, we can look at it first, right? And the first thing we would have to do is we would have to identify what is behaving as our anode. And that's what we are asked in part B. Well, the anode is always, remember, on the left side of cell notation. So our anode is going to be our Al, Al3 plus. That is our anode. And if that's the case, we know that the half reaction for that is going to be, it will look like this, right? And if that's the case, then our half reaction for our cathode will be very similar, but it's going to be with the right charges, right? And if that's the case, how do you combine these two so that you have a balanced, I apologize, the camera froze. How would you have a balanced chemical reaction? Well, you would want to cancel out their electrons, right? Because in our final equation or final reaction, there is no electrons. So you multiply by the correct coefficient, in this case, 3 for this one and 2 for this one. That will give you 6 electrons on each, and you can cancel them out, right? Now, if you bring that all the way through, we're going to have 2Al plus 3Fe 2 plus to 2Al 3 plus 3Fe. And that's going to give you your complete balanced equation for this cell notation. Okay, now if you build this even further, in questions 3 through 4, let's keep going, right? Well, in questions 3 through 4, it asks you, how do you do this if you're given the half reactions? Well, the half reactions that are given are Zn 2 plus 2 electrons to Zn solid, and then Pb 2 plus 2 electrons to Pb. Now, it also gives you the standard potentials for each, which is negative 0.76 and negative 0.13. From this, how do you consider the voltaic cell? How do you put it into voltaic cell notation? Well, you can look at it, and because you know that zinc is more negative, its standard potential is more negative. It's losing more electrons than it is gaining. We know that it is our anode, right? So we have zinc 2 plus, and then anode, cathode. Then we do Pb 2 plus, line Pb. So that gives us question 3, right? But question 4 further asks us, what is the standard Gibbs free energy change for the voltaic cell above? And it gives us, thankfully, it gives us a function, right? Which is G equals negative NFE. And it also gives us the value of F, which is 96.5 kilojoules over volts times mole. Well, what is G in this case? Since we know F, we can just put in F as is, and we'll just fill in the value when we put it into our calculator. But do we know our E, and do we know our N? Well, we know that E is essentially, let me put the equation for E. E is essentially going to be cathode minus anode, right? And if that's the case, we remember that this is our anode, this is our cathode. We go minus 0.13 minus negative 0.76. So if that's the case, we can essentially put that in, and we know that we have minus 0.13 plus 0.76. But do we know our N? Do we know how many moles we have? Well, we do, right? Because we can do that based on how many electrons were being moved around in this cell notation. And where can we look at that? We look at that up here, and we know that there are 2. So now we've filled in our entire equation, right? And we fill in for the value of F. When you calculate that, that gives you a G value of negative 121.59. Those were all 4 questions on the worksheet. This was to provide you a lot of practice with putting things in cell notation and putting things into an equation if given cell notation. I hope this made sense to you. If it didn't, please feel free to comment down below any questions you have or email me. I will be holding office hours on Thursday, so please feel free to come by.